So far, we've talked about electrophilic addition of strong Bronsted acids to double bonds. But what will happen if we attempt to add a weak acid, such as water or an alcohol, to a double bond? So if we try this just with water on its own, we're going to get no reaction because this is just not strong enough to protonate this. And the major problem here is during the course of this reaction, we would generate hydroxide. Right? So if this were to attack, some electrons would move, we would make hydroxide in that. And we'd have a carbocation. And those are incompatible species in this particular situation because we'd have something that's protonated and we'd be generating a really strong base. And so this just cannot happen like this. Instead, what we'll have to do is add an acid catalyst. Often this is sulfuric acid. So let's see what happens when we add water, but we add a catalytic amount of sulfuric acid. If we added a lot of sulfuric acid, then that itself, the H2SO4, would do the addition to the double bond. But if we have lots of water around, and then we just add some sulfuric acid, all right, catalytic amount, then we can add an alcohol or add water across the bond here. And form an alcohol. So let's just look at the mechanism for this process. Now, instead of actually starting with water to do that, because we know that's going to form hydroxide if we do, and that's not a good idea, we're going to start with protonated water, or H3O+. And then we'll have this do the attack. Now we've formed water as one of our intermediates, and that's much more stable than hydroxide in the presence of our next intermediate here. So we do this, we'll make this intermediate, which has the proton, the new proton right there. And then we'll bring in our water that we just have floating around in the solution. That attacks that positive charge. We get the new intermediate. And then we'll need to bring in some more water. To deprotonate and form the alcohol. And in the process of deprotonating this intermediate, we make both the product and reform our catalyst, because this will remake H3O+. Then we can make more of this reaction happen. Now, I mentioned that this works with weak acids, and water is an example of a weak acid. But we can also do this reaction using an alcohol as the weak acid. I'll skip drawing the mechanism because it's exactly the same as this one, except instead of having just hydrogens here, it's going to have some carbons in the place. So if we have this and we're going to add in, say, ethanol, and again, we'll need a catalytic amount of our sulfuric acid. then we can form, instead of making an alcohol, we will form an ether. So this is yet another way to make ethers. Now you'll notice that we're doing these additions Markovnikov addition because again we're trying to make the more stable carbocation. And so if you try to make an ether this way, just keep in mind the possible combinations that you can have, and you will not be able to make just a primary ether on both sides. You'll have to have a secondary on at least one of the sides just because of how it's going to add.